To state if these triangles are similar, we have to determine if we have either angle-angle similarity, side-angle-side similarity, or side-side-side similarity. I can see that angle S is congruent to angle E. That is marked on the diagram, so we say that that is given to us. So we do have a pair of angles that are congruent. So now we need to match up and see if the sides are proportional. So the 19 is the smaller of the two measures there, so it has to match up with the 50. And we want to see, does that equal? Obviously, then we would have to go 22 over 56. Again, make sure you're matching up correct parts to correct parts. If I reduce down, whether you used cross products or if you just reduce down, 19 divided by 50 does not reduce down, so that's 0.38. 22 divided by 56 comes out to about 0.392, and it keeps going. Are those two values the same? No, so the sides are not proportional. Which means I can't complete a similarity statement for something that is not similar. And we would say these are not similar. They do not meet the criteria. But the biggest part there is making sure we're matching up parts correctly. Taking the smaller measure and matching it up with the smaller measure, the bigger measure with the bigger measure. Everything has to be corresponding parts for this to work. Now we're moving on today talking about the basic proportionality theorem. If three or more parallel lines intersect two transversals, then they cut off the transversals proportionally. And I'm going to put markings on these lines here to show that they are parallel. So in this case, A over B would be equal to C over D. We could set up a proportion again as long as we know that the lines are parallel and they're cutting off two transversals. Then they're cutting off proportional parts. And as that one applies, you don't have to have a figure, we just have to have parallel lines. Then we do have a theorem that applies directly to a triangle, the triangle proportionality theorem, which is also known as the side splitter theorem. So if a line parallel to one side of a triangle intersects the other two sides of the triangle, then the line cuts off these two sides proportionally. So we can see segment BC is parallel to segment DE, which means that AB over BD equals AC over CE. So if we have these parallel lines, whether they're in a triangle or not, we have some proportionality happening that we can use to solve some problems with. Now, there is one more theorem that happens in this section on the next page, the angle bisector theorem. All right, in the angle bisector theorem, the angle bisector of a triangle divides the opposite side into two segments that are proportional to the other two sides of the triangle. So your angle bisector here, bisector means it's cutting that angle in half. It doesn't necessarily cut the other side in half, but it does create a proportion where we could say BD over DC. So that's the two segments of the side where the angle bisector comes in. And because I started with BD on the top, I have to go with the side that's adjacent to it. Would have to say AB over AC. So that third side is cut proportionally to the other two sides based on that angle bisector in the triangle. And we know we have an angle bisector by the arc mark showing us that those two angles are congruent to each other, which means the angle BAC had to have been cut in half or bisected. So now we need to see how we're going to apply all of these ideas. So it says find the missing side length. Again, because these two segments are parallel, we know that they are parallel based on the markings on the diagram. That means I can cut off the segments proportionally. Now, here I can use the full side instead of having to subtract. So I could say 3 over 2 equals 6 over x. I'm going to change that question mark into an x. And then I'm going to go back to my cross products that I've done before. Once we have that proportion, solving it doesn't change. So 3 times x equals 2 times 6. So 3x equals 12. If I divide by 3, x equals 4. All right, so our next example, again, I'm going to turn the question mark into an x. And the thing about this, you can go across from one side to the other, or you can go up. Again, it comes down to your cross products. So you could set this one up. You can match up the 9 with the 6 and the x with the 10, or you can go 9 over x equals 6 over 10. It doesn't matter whether you go across the figure or up one side. It just matters that you're consistent. If I go 9 over 6, I have to go x over 10. Again, I have to come from the same side. Just as if I go 9 over x, then it has to go 6 over 10. I have to go in the same direction. So it doesn't matter which way, just that you are consistent with whatever direction you're going in matching up those parts, And again, then we have our proportion to solve. So 6 times x equals 9 times 10. 6x equals 90. So what does x equal? 15. So again, the hardest part is setting up the proportion. Once you have that set up, we've solved enough proportions this unit. It's all about, the biggest part is you have to set them up correctly. All right, the next page. Pay attention here on number 3 of what parts you have and make sure that you match them up. Right now, the x that we're looking for is here. Problem is I don't have a measure here to match up to it, but I have enough information to know that this segment here has to be 9 minus 4, or that this segment has to have a value of 5. So make sure you're matching up the correct parts. Don't just look at the measurements on there and say, okay, use what I have. So I could set this up 18 over x equals 9 over 5. And again, do my cross products. So 9 times x equals 18 times 5. So 9x equals 90, which means that x equals 10. But again, the big part there is paying attention and making sure that we are matching up corresponding parts. That is what it all comes down to. If you match up the x and the 4, obviously you're not going to get the correct answer because those are not matching parts. Number 4, we're looking for this long side here. I know this bottom section here is 6, bless you. I know the bottom section over here is 3, but what is the length of this full side here? 7. Actually, I should say it only goes from here to here. That would be 7. We have to add those two together. So again, making sure we're setting up the correct parts. So x over 6 would equal 7 over 3. The 6 and the 3 are between the same two parallel lines, and the x and the 7 represent the same distance or the same part of the diagram there. Do our cross products. So 3 times x equals 6 times 7. 3x equals 42, which means x equals 14. But I cannot say it enough. The biggest part is making sure that we are setting up the proportions carefully, taking our time, making sure we are matching up the parts that need to be matched up. Number 5, I have an angle bisector, and I know I have an angle bisector because I can see that those two angles are congruent, which means that bigger angle was cut in half. Now, this is a little bit tougher mathematically. I cannot use that whole side of 39 because I'm matching up to the other two sides. If the whole side is 39 and that is x, that means that this here is represented by 39 minus x, because that's how I would find, if I know the entire side is 39, I would find the other part by subtracting the part I know. So if one side of it is x, the other side is 39 minus x. So 39 minus x over x equals 16 over 36. And again, I start with the 16 because I started with the 39 minus x. I have to start with what's adjacent to that, going from left to right in the triangle. And then I've got to do my cross products. So I have 36 times the quantity 39 minus x equals x times 16. So 36 times 39 gives me 1,404 minus 36x equals 16x. Now, if I add that 36x to both sides, I get 1,404 equals 52x. If I divide by 52, I get that x equals 27. So again, you may have to do a little bit of math to get the right parts and make sure that we're setting things up correctly and matching up the correct parts. All right, I'm going to pause while you do 6, 7, 8, and 9, and then we will come and check our answers. All right, so number 6, again, I've been seeing this error a lot. They give us this entire side here is 8, but they don't give us the entire side. They give us parts. If I know the bottom part there is 6, that means that this section here has to be 8 minus 6, which means I should be using 2 to match up with it. So I should be doing 2 over 6 equals negative 2 plus x over 9. You cannot match up an entire side to the parts. Now, the other way you could have gotten around that, you could have added the 9 plus the negative 2 plus x and matched it up that way. But that's the more difficult, instead of just doing 8 minus 6 is 2, because those two sides added together have to add up to that 8. And then do our cross products. So 6 times negative 2 plus x equals 2 times 9. So negative 12 plus 6x equals 18. Add that 12 to both sides so that 6x equals 30. And we should get x equals 5. But again, a lot of you out there were using the 8 in your proportion, but using negative 2 plus x over 9 for the other ratio. You cannot do that. Those are not parts that match up. We have to make sure we are matching up the correct parts. Number 7 is a little bit more straightforward. One of the ways you could set this up is 12 over x plus 3 equals 9 over 6. Now, you may have chosen a different way to set it up that is still correct. This is the one part about proportions. There's more than one way to set them up and still be correct. The thing is, do we have the same cross products? If you have the same cross products as me, then your proportion is fine. As long as those match up, as long as you're multiplying 12 times 6 and 9 times x plus 3, then your proportion is set up correctly. So if we do 9 times x plus 3 equals 12 times 6, 9x plus 27 equals 72, I believe. Subtract 27 from both sides, and we get 9x equals 45, which means x equals 5. Number 8, again, I know I have an angle bisector because I can see that the two angles there are the same measure, which means the larger angle has been cut in half. So I can set it up x plus 1 over 9 equals 8 over 12. Again, I went left to right on that bottom side, which means I have to go left to right for the other two sides. And then I have my cross products to multiply. So 12 times x plus 1 equals 9 times 8. 12x plus 12 equals 72. Subtract 12 from both sides, and 12x equals 60. And x equals 5. Now, I don't want you to think that the answer to every problem is going to come out to be x equals 5, though we have seen it 3 times in a row. It's coincidence. A bigger one than I would like, but it's coincidence. And then number 9. Now we have that 3 or more parallel lines cut by a transversal. Now, in this case, they gave me the whole side here is 2x plus 1, so I can match that up to the 14. I don't have to break it down because the parts are matching up, and then I have the 15 to match up with the 10. So 2x plus 1 over 15 equals 14 over 10. And again, more than one way to set up the proportion. You could have said 2x plus 1 over 14 equals 15 over 10. It's, do you have the correct cross products? Are you multiplying 2x plus 1 times 10, and are you multiplying 15 times 14? So 10 times the quantity, 2x plus 1 equals 15 times 14. So 20x plus 10 equals 210. We subtract the 10 from both sides, we get 20x equals 200. And then we divide by the 20 to get x equals 10. But again, the biggest part of this is setting up those proportions. And in setting up those proportions, we have to make sure that we are matching up the correct parts to each other when we set these up. You cannot just go with the amounts on the diagram, just use those. You have to make sure they are the correct amounts and see, do I have to do any subtracting or do I have to do any adding to match up parts? So we need to be very cautious with that.